Oper All right, operating systems and file systems. Here we're starting to get into the bread and butter of what we do. Now remember, this is just a brief overview. There's more classes to take on the details of all these, but we're going to talk about file systems and operating systems. We got to be, as forensic examiners, we got to be ready to examine multiple file systems and their different structures. You can't just say, hey, I'm a Mac guy, or hey, I'm a Windows guy, or hey, I only work on Linux. You got to do them all. You got to understand a little bit about both, but sometimes you can't be an expert in every one of them. A file system is what is used to control how data is stored and retrieved. Without it, there'd just be crap everywhere in the drive. A lot of your digital video recorders work this way. They don't have a file system. It's all just in the hard drive, and there's a chip on the motherboard that controls and understands where all the data is written. So this is basically kind of like looking like a file cabinet. The file system is how all the files are in each drawer are labeled and put together so you can find things easily, like the old Dewey Decimal System in the library. Remember libraries, those places that you used to go to when you were a kid? Maybe you don't. Linux. Linux supports a lot of different things, and a lot of people really like Linux systems. You'll see them in a lot of commercial applications, web hosting applications. You don't see them too much in everyday computers. If you run across a Linux machine, you got somebody who's a little bit more technically savvy than the average Joe user. And basically, they use a lot of different. The ext is the most common file system that you're going to find in a Linux system, but they can use just about a lot of others too.
Okay, so let's say in Linux you open up your file manager and you're in your home/user directory. Well, click the up arrow or the back arrow to go up a couple of levels to the very top. The very top level in Linux is just a single /, and that's called the root directory or the root partition. All other folders are located under root, under this root partition, if you will. So that's the very top level. It's just a single /. Now, you'll see a list of directories if you are looking in your Linux file manager, like Conquer, for example. And there's going to be some differences in distributions. So I'm going to list out a bunch of directories, and you should see these, and you may see some additional ones. Don't worry about the additional ones right now. I'm just going to kind of give you the overall picture, and then some distributions are going to do things a little bit different. But more often than not, the basic directories that you will see under root are the following: bin, that's bin, dev, dev, etc, etc, home, lib, lib, mount or mnt, proc, proc, root, spelled out root, sbin, temp, which is tmp, usr, and var, var. Those are kind of the basic directories that I think you'll see in every Linux distribution. Don't hold me to it, but basically that's what you'll see in every Linux distribution. Now there may be some additional ones, but these, from what have found to be sort of the basic directories. So what I thought I'd do is kind of go through these and explain to you what they are and point out some things about them, and then you'll see hopefully how this whole thing fits together. The bin directory stands for binaries or binary, and that is where some applications, some programs, some scripts that are accessible to all users will be located. For example, there's a common command in Linux, ls, and that little program is located in the bin directory. So the bin directory contains some programs that are accessible to all users. Okay, dev, this stands for device or devices. This is a virtual directory, meaning there's no real subfolders, generally speaking, in this dev directory. because Linux treats everything as folders and files, when you first boot up your Linux distribution and it starts detecting your hardware, it will place folders and files representing your hardware in the dev directory. There used to be something called the, I think it's the dev FS, which was what would detect, it was that and Hotplug, which would detect your hardware and then create what are called nodes in the dev directory. Nowadays, really modern distributions and something that most distributions are heading towards, it's being handled by something called udev. But in any event, the dev directory contains these virtual devices, these virtual nodes for your hardware that is detected by the Linux distribution. All right, the next one is etc, etc, and that, I think that stood for etc. This is a very important directory. This is where your configuration files will be stored. A lot of Linux applications that are run at the command line, or even ones that are not, will store their configuration settings in a text file. Well, really everything's in a text file in Linux, but the configuration settings for particular programs will be located generally in the etc directory. The etc directory will also have subfolders for your initialization, your run levels, which is something we'll talk about another time for Linux, where you boot up into single user mode or multi-user mode or whatever. Those kinds of scripts and configuration files will all be located in the etc directory. The next directory, home, this is the default directory where user subdirectories will be created. If you create a new user, called Joe, and you've got it set to create a subdirectory or a home directory for Joe, that will be in home. So it'll be /home/Joe. That will be Joe's home directory. The next directory is the lib directory, and that stands for libraries or library. And this is where the shared libraries are stored. You may have heard of things like Perl and Python and C and all of that. Well, those tools have libraries that are used by different applications in Linux, and they share those libraries. And those shared libraries will be located in the lib directory. And the lib directory is also where what's called your kernel modules are located. Okay, the next directory is the mount directory, or the MNT directory. And this is a neat directory. This is an important one as well. This gets to those hard drives and floppy drives and CD-ROMs that I talked about. In Linux, your drives, hard drives and floppy drives and CD drives, are mounted. That's the term that's used, meaning plugged in to the directory structure. And the way it works is you create a folder or a location for, say, your CD-ROM. And it will be, for example, the mount/CD-ROM directory. So it would be /MNT/CD-ROM. That would be like almost like your node or your your pointer, your location for the CD-ROM. Then when you actually connect the CD-ROM, when Linux detects it on boot, if it's set up right, what it will do is it will mount, it will connect the CD-ROM and connect it to that location. So if you put a CD in there, into the actual CD-ROM, the contents of that CD would be located at /MNT/CD-ROM. And the same thing would be for your floppies and USB sticks and other kind of media. You could have /MNT/floppy or /MNT/jump drive if you've got a USB jump drive. You can call it whatever you want. You can make these directories as root and set up your Linux to mount your devices at these various subdirectories. And like I said, I realize this may be getting advanced for some people, and this will make more sense as things go along. But what is really cool about this is that if you kind of think about it, what this means is that you can really create your what are called mount points wherever you want. And this is why the Linux file system is so much superior to Windows, I think. Rather than Windows, which is based on the drives, Linux is based on just a single big long file system, and you can plug the drives in wherever you want. Here's a perfect example. This is a real life example for me. I have an extra hard drive that's got all my music on there. I've got, gigs of music that I've ripped off my CDs and stuff. Well, I have my Linux distribution set up to mount that hard drive. When it boots up, it mounts it to my /home/chess/music directory. So when I'm in my home directory, there's a little folder there that says music, and I double click on it and it opens up that folder, and there's all my music. But all that music is located on a secondary drive. But it's transparent as far as your usage of it goes. In other words, it looks like it's just a folder in my home directory. If I didn't know better, I wouldn't have no idea that the contents of that folder are located on a separate hard drive. It could be a network drive. And you can start to see where the networking potential of Linux, where it really gets, this file system comes from Unix, and it's a network-based file system. You can have hard drives located across the network or resources located all across the network, and you just mount them at different locations. And when the user comes along and looks at the directory tree, they have no idea where things are. One directory could be mounted locally on this particular workstation. Another directory could be mounted over a file server somewhere, across town or whatever. And it doesn't make any difference in the sense that you can just plug these things in to the directory wherever you want. Now, I'll explain how you do all that another time, but I'm just kind of giving you the conceptually the way it works. Hopefully I'm explaining this well. It's one of these things that I know how it works, and I've been thinking about how to explain it, and hopefully I'm making sense. Okay, let's pick back up with the list. So that's the MNT, or the mount directory. The next directory is the proc, P-R-O-C, and this is another virtual directory, kind of like the dev directory. This virtual directory will contain information about your system. This is where you can go into this directory and you'll see information about your processes that are running, your PCI bus information when you're talking about PCI slots and ISA slots, and just everything regarding your hardware of the system is going to be contained in this virtual directory, this virtual folder. All right, the next one is the root directory, the spelled out root, R-O-O-T. This is the default home directory for the root user, and the root user is the administrator of the entire system. This is where their home directory is. It's not going to be home/root. It will be just root, and the reason for that is just for security. If you've got all your regular users with home directories, in home/Joe, home/Bob, whatever, you want to contain them within that section and not have them really see the root directory, if you will. But anyway, so the root directory is separate from the home directory. Okay, the next one is sbin. And you'll notice it sounds like bin, the first one I mentioned. And I think this stands for secure binary. But anyway, what this directory is where certain applications and programs are located that require administrative level privileges. These are programs and applications and things that normal users wouldn't be using. A good example is fdisk. You may have heard of fdisk. That's kind of like a partitioning tool. Well, that's kind of a powerful tool, and you don't generally want your average users to be able to use fdisk. They could partition the disk and mess things up. So that's a administrative level application that will be located in sbin. All right, the next one is the temp directory, TMP. As you can probably guess, this is a temporary directory, or a directory where temporary information is stored. Sometimes, if you're running different programs, it will temporarily save a log that will then be erased when you close down the program, or it can just be for anything. And I think most distributions are set to empty the temp directory upon reboot, so you wouldn't want to do anything permanent in here. Sometimes I'll unpack a piece of source code in this directory and then move it or something, but anyway, that's just a temporary directory. All right, the next one is a very important directory, the USR directory, and that stands for Unix System Resources. A lot of people think that the USR means user, but that's not what it means. It stands for Unix System Resources. And this directory is going to have a lot of subdirectories in it. And it's got like USR/bin, USR/include, USR/lib. And this, generally speaking, is where shared data and shared libraries and shared binaries, meaning applications, will be located. Because Linux has a networking and a Unix root, background to it, a lot of times the way things would be set up is that you would have a, sort of like a server, or you would have it set up where you could have thin clients or separate clients attaching to a server that will hold all of these applications and libraries. And so the USR directory is where some of this shared data will be held. Generally, the stuff that's in the USR directory is not host specific. In other words, this is not where you would generally find data related to the specific machine that you're running. Now, there's some exceptions. There's a subdirectory in there called USR/local, and that is where you generally will store local data. Or to put it another way, if you install an application after the fact, let's say you've got your Linux distribution up and running and going, and you go out and you get a separate application out there and you install it, sometimes that will often be installed in USR/local. And because the thinking is that's where you can keep all your local stuff, that's not going to be touched when you upgrade the system, because your Linux distribution is not going to install anything in USR/local. Only you would. Only the user would. So you can put stuff in there and be reasonably sure that it will stay safe. There's a lot more to the USR directory, and I've barely scratched the surface because there's just a lot in there. But anyway, check out USR/doc. That's where a lot of documentation is held. That's a great directory to check out. And then the last one is the var directory, and this stands for variable files or variable data. This is where a lot of things like log files are held, or databases or websites, or a lot of times the Apache web server is set up to manage its base file location in the var directory. And this is where a lot of this is where the cron jobs, I think, are generally run, and there's just a lot of variable information. And your if you run an email program, email server, the mail spool file will be in the var directory. And there's a lot of stuff in the var directory that can fluctuate and change. And so oftentimes it's set over on a different partition. And that's also something else we'll talk about. But that's what the var directory is for, basically logs and spool files and things like that. Now, those are sort of the basic directories. There are some additional directories that sometimes you'll find in certain distributions. Oftentimes there's a boot directory. This is located at the top level. In the root partition, you'll have, after bin, you'll have boot, and that will be where the Linux kernel is held, the Linux kernel config and system map files. Some of the bootloaders will store some of their information in the boot directory. There's also oftentimes a media directory right off root. You'll have, instead of MNT, you'll have MNT, but you'll also have media. And the reason for that is I think the standards actually calls for MNT directory to hold your, I think it's your temporary shared mounted partitions, network type partitions, network type shares, and the media directory is supposed to be where your removable media is mounted, like CD-ROMs and USB sticks and that kind of thing. Some distributions I've noticed use the media directory for things like CD-ROMs and USB sticks, but it seems to me that most of them still stick those in MNT, so it just kind of depends. I think PC Linux OS still uses MNT for everything, CD-ROMs and USB sticks and everything, but I could be wrong about that. Oftentimes you'll see an opt directory, OPT, and I'm not sure if that stands for optional or not, but it is kind of optional because I see it in some distributions and I don't see it in others. And that's kind of like optional, I guess, sort of I've heard some people describe it as sort of like a sandbox or a testing ground, kind of like a place where you can install applications if you want. Some distributions actually install stuff there in opt. I think Arch Linux is one, and there's been a couple others I've noticed that actually use opt, and that's where they put packages that are installed. But I'm not quite sure if that's what the standard is or not. I don't think it is. I think it's still USR, but anyway, the opt directory is often found in distributions, and when it's there, it's usually for extra or additional packages that are installed later on. In other words, you generally don't find any system critical information in opt. It will be like, let's say you upgrade Firefox. Well, it might install the new Firefox in opt. Or OpenOffice, I think, is a classic example. I think OpenOffice has always installed itself in opt. It's such a big application, they just figure, well, let's just stick it someplace else where it won't bother anybody else. And so I think that's more or less the file systems that you generally see. As I mentioned, some distributions do things a little bit differently. Some distributions will have things in different places, but there is a standard, and I will have a link to the file system hierarchy standard that has been adopted, and I think by the Free Standards Group or somebody like that, and check that out. There's some good reading there.
Here's what Linux looks like in using FTK Imager. You'll see an ext4, or ext2, or ext whatever it is, and you'll start to see the breakdown from there in your root systems. So that's what you look for when you start seeing, oh, hey, look, I got a Linux file structure in this partition. OS X, better known as Mac. OS X uses HFS Plus, or Mac OS X Extended. This is their version, and you got to remember that these things come off of Linux. They're Unix style systems, and Unix comes from way back in the day. And when you're reading these things, they're not always compatible with each other, but OS X, you got to understand, is built on top of Unix, just like Linux is. When you look at it in Imager, you're going to see Mac boot, HFX Plus. There you go. Hey, I'm dealing with a Mac partition. You have to understand that you're going to be dealing with the Mac file structures.
So here I am on my Mac, and I want to show you at the top level of your system volume, there are some default folders. Double-clicking on the Macintosh HD, we see Applications, Library, System, and Users. You may see more than this if your computer has been in use for a while and you've installed some things. If it's been around for a long time and upgraded, you might even see something like a developer folder. But these are the 4 standard ones that pretty much everybody should see. The Applications folder is, of course, a place where applications are stored, but these applications will be available to the local computer domain. Everybody on this computer will be able to run applications that are located inside the Applications folder, unless there's some other restrictions that we're not going to get into in this lesson. Then we have a Library folder. This is a place for resources, things as different as desktop pictures and log files. We also have a System folder, and that's exactly what it is. It's the operating system. It is a place where you really should not make any changes on your own. This is for Apple to manage, and it's where Apple puts its operating system. Then we also have a Users folder. This view that we're looking at right here is, in my opinion, a little hard to explain what's going on. So I'm going to switch over to Columns view. And then I'm going to push my window to the left, make it a little larger to the right. And I'm going to leave the icons of the disks visible because I want to show you something there. I'm going to use the go command to go to a new folder, and that folder is going to be called /volumes. And I'm going to press return. Notice that this Applications, Library, System, and Users folders is now joined by a volumes folder. And the volumes are the names of our disk volumes that we formatted in a previous lesson. These actually are located as part of the file system, and the only one that's the odd man out is the Macintosh HD, which is our system startup volume. Notice that it's got a little bitty arrow. In fact, if I use the Get Info window, we can see that this is a kind of alias. And really what it's pointing back to is the original location highlighted here of /. That's called the root of the file system. More about that when we talk about the command line, but just know that you can always go into volumes and see what disk volumes or even network volumes are connected to your computer. We also have some hidden folders other than the volumes folder. So let me go back to the Go menu, say Go to Folder again, and I'm going to type in /private. Now this will show us the private folder, and inside the private folder are 4 other important folders: Etsy, TFTP boot, which is not that important really for our discussion, and TMP and var. etc holds a bunch of configuration files. They are typically Unix type configuration files, but Apple has put some of its own flavor of files on there, like the one I just highlighted. Temp is really a place for cache files, temporary files, that sort of stuff. Var is a place for variable information like log files. So if you go to var log, you'll see all sorts of log files. Now, it's not the only place for log files, but it is a traditional Unix type of path to log files. I have also provided you in your lesson materials some script commands that we're going to use to see a whole bunch of hidden files that are at the top level of our computer. Let's go back to Macintosh HD, just highlight that, and notice that we still see the private and volumes right now. If I were to close the Finder window and double click on it, they'd be gone. So we'd have to say go to folder to get them there again. Now for troubleshooting purposes only, you could use something like the scripts that I provided. One is show all files yes command, and the other is show all files no command. Just double click on the show all files yes command. It should bring up the terminal automatically and run. If it doesn't, if it warns you that this was downloaded from the internet or copied from some insecure place, you're going to have to do a right click or secondary click on it and say open, and then run it with the terminal that way. So let's go back here to the Macintosh HD window, close it, nothing's happened yet. Double click on Macintosh HD icon and notice all the hidden stuff that has now become visible. Now don't mess around with any of this because bad things will happen usually. Notice that a lot of these grayed out items have really weird Unixy type names. sbin, bin, cores, mock kernel, net, and so on. So be careful using something like this. It's okay for troubleshooting purposes, but when you're done, change it back. And here's how I would change it back. With my little script that says show all files no, double click that, let it run. No changes in the Finder window yet. We have to actually close Macintosh HD and reopen it again to get back to the state where we just see the Applications, Library, System, and Users folder. So now you know that there is a world of files and folders that are hidden from the user, and this just keeps the complexity level low for the average person. If you need to see them, you can use something like the scripts that I have provided in order to turn on the hidden files and turn them off, or as Apple puts it, show all files yes or show all files no. So next up, we're going to start looking at the user home folders, and to do that, we're going to need some more users other than just this one admin user I have. So I'm going to go into my system preferences, users and groups, and I'm going to create a new user. So I have to click on the lock, authenticate as the local admin, click on the plus, and fill out the information for a new user. Then I click on create user, and it may take a moment. Usually it's pretty quick. And now we have Hugh created and ready to go to the next lesson.
FTK2, we have supported the HFS, HFS Plus, and HFSX file systems. However, recently with the release of FTK version 3, we've added support for many artifacts relating to the Macintosh world. To begin, let's demonstrate or show the support of DMG images and also DD disk images. So those are both supported now and can be added to FTK as a piece of evidence. When added as a piece of evidence, these are fully processed just like any other forensic image. We've also added support for property lists, or P-lists as they're known, within the Macintosh environment. P-lists contain user data and preference data for many different applications. One good example of P-list support would be the Safari cache. In the image you can see here, I'm going to go ahead and expand out this image of a Macintosh computer and drill down to where the Safari cache should be located. I'll go into the Users folder and down into a user called FTK, and further down into the folder Library, and then down into the Safari folder. Within the Safari folder, we can see several P-lists that reside here. For example, there's the Bookmarks P-list, and this P-list can be viewed in a HTML rendered view simply by using the Natural tab within FTK3. We can see several bookmarks presented here along with the accompanying data for them. Also, the History P-list would be another example, the Last Session P-list, and many other P-lists that are resident in the Macintosh file system. Going back to the History P-list, we can see all of the data that is parsed out, including the last visit count, date, URL, and other accompanying information. In addition to basic P-list support for XML version P-lists, we also support binary P-lists within FTK3, and they're rendered exactly the same way. To accompany the P-list support, we've also added support for SQLite databases, which are found in many Macintosh and even Windows related applications these days. One good example of this would be the Safari cache. I'm going to scroll up a little bit and go into the caches folder, and then I'm going to go down into the com.apple.safari folder. Inside there you'll see the cache.db, which is the SQLite database. By clicking on that, we can expand it out and see all of the tables within the database itself. The first folder, the CFURL cache blob data, is the actual data that's contained in the database, such as pictures, and web pages and so forth that the user may have visited. Here's one that's identified as number 255 within the database. By going to the next folder down, which is the CFURL cache response folder, I can take a look at the table that identifies all of the different entries in the database and their corresponding URL. And I'll scroll down to 255 and find the original name and URL for that particular item. Now, one easy way to keep these two pieces of the database in easy view is to right-click on the table and open it in a separate content viewer. Now it can be moved around while you continue to look at the blob data and take a look at the different items, identifying any of interest, and then going back to the content viewer to look at the additional information for that. Also remember that all of these items, to include the blob data and the table information, can be bookmarked as separate items within FTK for documentation purposes. In addition to supporting SQLite databases and plist files, we also now support the attributes B tree within the Macintosh file system. So I'm going to go ahead and close up this data area here, and we'll go into another evidence file called the attributes btree.e01. When you are using a Macintosh mail program such as MacMail, you are allowed to save images sent to you via email as files on your computer. When you save those files to your computer, they are stored with some attribute information that you would normally access in the Macintosh world by right-clicking the file and choosing Get Info. Here's an example screenshot of what you would see when you right-click the file and choose Get Info. You can see the information presented about the file, and more specifically, under the More Info area, you can see a field called Where From, showing that this file was sent from kwarren@accessdata.com to the user. This could be very important information in cases involving email and images. Going back to FTK, we can see that same image present in this image file called the attributes btree.e01, and I'll go ahead and expand that out, and we'll take a look at the contents of that particular folder. And you can see the image right here, and I can view it in the content view, but I can also look at the properties window for that image. Let me shrink this down a little bit where you can see it, and I can see some information, specifically the where from field that is pulled from the attributes btree. And we can see in that information we've got the kwarren@accessdata.com information, as well as the message ID. So this would be a great way to tie a message back to a particular sender, or an image back to a particular sender. And that is just one example of an attribute information that could be pulled from a Macintosh HFS file system. In addition to supporting the attributes tree, we also now support JSON files, and those will be rendered in an HTML version, an HTML view for you when you click on them. To support the possibility of file vault and or encrypted sparse bundle files, we have the ability to not only break the user's password, but also attack the sparse bundle file itself. Now this is not done within FTK, but more appropriately done within PRTK. To do that, you would simply go and find the user's hash file, and in this case I'll go into my Macintosh image, down into the single partition here, down into a folder called private, and then var, and then db, and shadow. Inside the shadow folder we find a hash folder, and inside that folder we find several files. The single hash file without an extension would be the hash file that you would drop onto PRTK and attack as a dictionary attack. This would be a standard dictionary attack for the SHA-1 hash value. Once you have that value, you would have the logon password for the user, and very likely the same password used to access the file vault itself. In addition to breaking the hash file for the Macintosh login password, we can also attack a sparse bundle if that sparse bundle happens to be present as a file vault file, or if it's present as a separate encrypted sparse bundle on the file system. I'll take a look here in the image called metadata test, and you'll see inside this image that I do have a sparse bundle, and those are represented as a folder structure within FTK with a .sparse bundle extension. Inside the sparse bundle folder itself, you'll find a file called the token file. You can attack this file with PRTK as a dictionary attack to recover the sparse bundle password. You can identify it as an encrypted sparse bundle because it does not contain files, and instead contains a folder called bands with these individual band files that are the encrypted data. As soon we hope to support the actual mounting of this sparse bundle within FTK. However, right now you can attack the file for passwords and then utilize a Macintosh file system to actually mount and extract the data from the sparse bundle file. And lastly, while we're in this folder, or in this evidence item, let me show you new support for EXIF data, or metadata relating to images. Go ahead and click on this item right here, and you can see that this particular graphic image, although I can view it in the natural view, also has a sub-item that is the metadata for that particular file. I can click on that sub-item and I can view the metadata in the file viewer to include the camera make and model, date and time it was taken, and so forth. This piece of information can now be bookmarked along with the original file to document the EXIF or metadata for that particular image. So that'll about wrap up the demonstration of the new features relating to Macintosh file system and artifact support within FTK3. If you have any questions, please don't hesitate to contact us. Thank you.
Good old Windows. Windows makes use of the FAT, File Application Tables, NTFS, exFAT, and RS file systems. And Windows has developed over the years because of file size limitations of the FAT to use NTFS. And typically right now, what the Windows we're seeing is mostly NTFS, but you will every now and then see the FAT. Again, here you're looking at, it says right there, NTFS. You know you're dealing with a Windows partition. NTFS came out with Windows NT in 1993, and it's been pretty much the creme de la creme for Windows ever since now. Windows 10, God only knows if they're going to change something. They're not talking too much. The FAT was the most common before that. You'll still see a lot of FAT file structures. You'll see them in thumb drives. You'll see them in a lot of different devices sometimes too. So you got to understand the FAT also.
In this lesson, we're going to be talking about file systems, and specifically, we're going to be talking about the file systems typically associated with Windows. Now, going back to the 1970s, there was a file system that was just simply called File Allocation Table, and what that represented was the way that files and directories were stored. They were stored in this file allocation table. Now, we've still got FAT, or file allocation table, disks around. You'll see them a lot on, for example, USB sticks. So I've got a USB stick here. It's actually formatted in FAT format. It's actually specifically formatted in FAT32. So the original FAT was a 12-bit file system, and so now we might call that FAT12. That gave way to FAT16, and now we have FAT32. The big differences there are the file sizes as well as the drive sizes that we can support. So this is a FAT32 disk. There are some limitations with FAT32 disks. Now, one of the limitations is the fact that they don't really have anything in the way of permissions, for example. So I've got this folder properties here, and it's called configs, and you can see that I don't really have anything that I can do with it. There's a read-only attribute, a hidden attribute, and an archive attribute, and that's really it. That's all I've got. Now, you'll see pretty commonly these FAT file systems on devices that need to be really portable, because FAT is such a common file system and it's been around for so long that pretty much everything supports it. So a USB stick is going to come formatted FAT by default because every operating system is going to be able to read it. Memory cards in cameras are probably formatted in a FAT format, again, because it's so portable, everything can read it. Now, when Microsoft was developing Windows NT, they decided that FAT wasn't a good enough file system anymore. And so they went to FAT32. You can see the file system here is NTFS, and this is the C drive. I can bring up properties on a directory here. Now you can see, again, I've got the read-only attribute and the hidden attribute, but across the top, I've got several other capabilities, the big one being security. Now, with the FAT file system, I didn't have the ability to set permissions on any of the files or folders because there were no attributes like that. We didn't have the ability to have multiple users in a Windows system until we started using Windows NT. So now I've got this ability to set different permissions, and you can see I've got full control, modify, read and execute, list folder contents, read, write, and special permissions. So I could actually remove some users who had permissions on these files, and I can add users who have permissions. So I've got all of these abilities to set permissions on files, which gives me a lot of flexibility in terms of who gets to see them, particularly if this is like a server operating system where multiple users could actually get access to my files. I might want to prevent them from being able to write to a file. I may want to allow them to read the file, but not actually write to the file. So along with permissions, I get a number of other features in NTFS. Now, in other lessons, we've talked about alternate data streams. I get alternate data streams with NTFS. I also get encryption. So I should be able to go to advanced here, and now I can encrypt the contents here to secure the data. So NTFS has an encrypted file system among one of its features. You could actually encrypt individual files or folders. In addition to encrypting it, I can also compress them. So the file system has the ability to compress as well as decompress files and folders within the file system. Now, you'll also see that there's indexing. So NT also supports indexing, which allows for faster searches of the file system. One thing that you don't see very often, although it's there, is this idea of journaling. So what a journal is it keeps track of all of the writes of the file system, and anything that gets modified, it keeps track of all of that in a log. So if anything bad were to happen, it can go back and check the log against the actual file system and see whether they match up. If they don't, they can reapply the log and recreate the data that may have been lost through, for example, a power failure. So journaling is really important. Having that ability to log transactions on the file system, just like you do with a database, is really important. Now, one thing I can do with NTFS that I can't do with the FAT file systems is to create links. So what I want to do here is I'm going to run make link, and I'm going to say I want this to be a hard link, meaning that anything that changes in the link also changes in the target. So I'm going to say new koala.jpg, and I'm going to point it at koala.jpg. Now, if I do a directory listing here, I've got koala.jpg and I've got new koala.jpg. And they look identical because one actually points directly to the other. It's not a shortcut to that, like you'll see when you create shortcuts, you'll see it says shortcut. This isn't a shortcut, it's actually linking directly to that koala.jpg. So NTFS gives me the ability to do these hard links. In addition to that, I also get things like quotas. So I can set a specific quota for a particular user, and they can't go above, let's say I give a user 2 gigs. They can't go above that 2 gigs. Something else that NT offers me the ability to do is have volume mount points. So I can go into Disk Manager here, and I could actually, let's change the drive letter and paths. I'm going to remove that E. And now I've just got this USB stick, and I can change the drive letter to mount into an empty NTFS folder. So let's say I'm going to say USB here, create a new folder, and I'm going to mount that USB stick into C:USB. Now, if I go back here, if I go into C, you'll see USB, and it's actually going to bring me to that USB stick. And it's now mounted as a directory rather than a different drive letter. So in Windows, we have drive letters, unlike Unix, where we have mount points. With NTFS, we also have the ability to do mount points, much like we do with Unix-like operating systems. Again, I've got this directory now called USB that's actually a mount point for this USB stick that I've got inserted. So with NTFS, I've got all sorts of capabilities that I didn't have with FAT. Again, we've got journaling, we've got hard links, encryption, compression, quotas, and permissions, among many other features. Now, with the current Windows operating system since about Windows XP, NTFS has been the default preferred file system, although you can still use FAT32 as your file system. But NTFS has been the default preferred file system for all of the reasons that I mentioned that NTFS gives users capabilities to do.
Well, look at this. Hey, a GPS using a FAT32 file system. A Garmin GPS uses a FAT32 file architecture. So you know that you can find these things in just about any device out there, and you got to be prepared. So oh, well, hey, I understand FAT, I understand FAT32, I can examine this. exFAT. Again, the exFAT is something that you will see every now and then. It is supported. It appears like Linux and FTK, and exFAT is a nice way because it is supported with the newer Windows and in Mac OS X. So you can go back and forth. Like if you have a thumb drive and you need to go back and forth between a Mac and a Windows machine, you can use exFAT to do that. And then that's where you'll see a lot of these things. Can you have multiple file systems? Yeah, you can. Because you can have a Linux partition on your drive, you can have a Mac partition on your drive, you can have whatever you want. You can have them all put together, and you can see something like this where you're like, oh boy. And you can even find stuff where it's an unrecognized file system. What might that be? Don't know. One of the things you have to understand is you got to know what you don't know, and that's it right there. Say, hey, I don't know what that is. And you have to be able to partition and examine and work at every one of these things. All right, your lab, week 3, lab 2. Answer one question and respond to 3 of your classmates. And one page describing the boot process of Windows XP 7 and 8. Good luck.